Case study number 1, airflow remediation. In this case study, we will review how an existing data center customer who was already invested in white space cooling optimization, or WSCO, leveraged AI to optimize their cooling in the space. With the information gathered from the system, they were able to make data-driven decisions to achieve operational excellence. The customer's goal was to fully eliminate hotspots. Let's look at their white space before remediation. This is a list of the hottest rack sensors in the facility. In yellow, we see the sensors showing temperatures above the desired limit of 80.6 degrees. We locate the sensors on this thermographic image of temperatures across the data center floor, which shows warm areas in the hot aisles, but also a couple of hot spots in the cold aisles. And we also see some very cold spots too. This is a common byproduct of hot spots driving overcooling. Note that at this point, the system had already optimized operations and is cooling the space with 5 units down from 9. The units turned off are indicated in black, and those that are turned on are shown in blue. We then review the trended temperature data from the hottest sensor in the room. It has been consistently high compared to our upper limit of 80.6 degrees, and you can see that there are times it's exceeding it. When we trend the data for all the rack sensors, we see a wide distribution of temperatures with a lot of outliers at the top and the bottom. Ideally, you want a tighter cluster of temperatures with fewer outliers and no temperature violations. This is possible through physical airflow remediation on the white floor. Let's go back to the thermal map. The key to effective airflow remediation is to leverage the real-time data collected from the system to directly target the problem areas. In this case, the customer rearranged perforated tiles, removing them from the areas around the cold spots and adding them to the areas around the hot spots. This redirected the cold air from the underfloor plenum to the areas that really needed it. Because the thermographic image is updated in real time, they were able to see whether the changes were effective. Overall, the entire remediation process only took 2 hours. They relocated 50 perforated tiles to better locations. Once the remediation was complete, the artificial intelligence used machine learning to rebalance cooling in the room for better optimization. And these were the results. This is the thermal map after airflow remediation and AI optimization. We see our hot aisles right where we want them, and we are no longer overcooling the space. Guided by the thermal map, they successfully eliminated the hot spots from the cold aisles, and they've also eliminated the overcooled spots. Also, notice that there are only 3 cooling units running in the space. This facility originally started with 9 units running before installing AI. The WSCO system then used AI to optimize the space down to 5 units. After the remediation process, AI was able to relearn the environment with the changes and optimize cooling expenditure, safely turning off 2 more cooling units, and is able to provide sufficient cooling with 3 crawl units. Let's look at the trended temperature data post-remediation. Now the temperatures are clustered closer together, and we have virtually no outliers. You can see here that temps across the board are lower than 80.6 degree limit, which means that the customer is now seeing ideal temperature compliance. And the amazing thing is that they're achieving this result while using less cooling, and the power usage data proves it. Let's take a look at that data. Now we're trending the instantaneous power usage of all the cooling units in the room aggregated together. Here, before the customer performed airflow remediation, the power was steady at 40 kW. Here we can see a spike showing a record of when the customer performed airflow remediation. And after the remediation process, it's down to 29 kW here. And then later, after the AI did its own optimization and was able to turn off 2 cooling units, the total power usage is down to 23 kW here. So total power usage went from 40 kilowatts to 23 as a result of the airflow remediation and AI optimization. That is a significant improvement.